Greetings and welcome to the introduction to astronomy. In this lecture, we are going to talk about the detectors that are used in astronomy. So how do we looked at gathering the light with telescopes, but how do we actually record that? So let's go ahead and take a look. And what was the earliest? Well, the earliest thing we had was the human eye, and you could draw what was seen. For example, these are Galileo's drawings of the moon. The difficulty with those is that it's very subjective. 10 people drawing the same object would always draw things a little bit differently. So nobody sees everything exactly the same. People don't pick up on maybe the exact same details. And while the overall structure might be the same, certainly it would not be exactly the same from person to person. Starting in the 1800s, we had photographic plates that could be used. So these were a glass plate that had a light sensitive film on them. And then that could be exposed and recorded. So these could actually be relatively large sized, maybe even 6" by 6" and could cover a decent area of the sky. Here we see one looking at the Orion Nebula. Now, the problem with them is that they were inefficient. Only 1% of the light is recorded. They're difficult to store. Why are they difficult to store? Well, first of all, they're glass, so they have to be stored carefully. But because of the photographic emulsion on them, they would have to be stored in a very climate controlled area, specific temperatures and humidities. And of course, to share the data directly would be difficult. If you want someone else to see the plate, you either have to send them the plate carefully, or they have to come to your location where the plates are stored. So what is used now? Well, modern astronomical detectors use a charge coupled device. And you're familiar with these in terms of cell phones use this same kind of thing for photography to record images. The nice thing is that they are much more sensitive, so they detect more light. And of course, they're a digital readout, so you can actually see your images right away. With a photographic plate, you'd take your images and you'd have to develop them at the end of the night to see what you got. And here you can at least get a look at what you saw right away and know whether you need to check something again, or if there was an issue with any of your observations. So how does a CCD work? Well, again, I said they're very efficient, 60 to 70% of the light being recorded. But essentially the light strikes the surface and produces electrons. And those electrons are stored in the little counters here. And at the end of the exposure, then the electrons are counted. The more electrons, the more light that hit that specific pixel. So how much light there? Well, how many electrons were there? That would be brighter area. And those with very few electrons would be the darker area. So, and then you would have again a way of reading them out. So you'd have to read out electronically how many you had. You'd transfer the electrons and count them as they came out. And that would then tell you the brightness. And you do that for again millions of pixels if we're talking megapixel CCDs, or even billions of pixels. So it is a detailed process, but one that again you're familiar with every day. And of course, it is a digital recording, so it can be analyzed and shared immediately. So you can send it to a colleague across the country, across the world, and have them look at it and get their opinion. And you can know in real time, of course, whether you need to continue studying that object or take a different exposure to look at that object in more detail, or if you can move on to the next object that you want to look at. So it's a little bit different than what was done with photographic plates, or of course with the naked eye. Now the other thing that can be used here is the spectrum. Now we talked about spectra previously in a previous lecture, and the spectra again we can use a device to split the light into its component colors. So here we have the telescope, we send it through a slit and do it here and then send it through a prism and through the lens, and then we get an image. And we can then look at a spectrum of it. Remember, the different wavelengths are bent by differing amounts. And the spectrum can then be recorded on a CCD and analyzed. You could also do it on a photographic plate. So you could put a photographic plate there, or currently you would put a CCD there to be able to record that digitally. And again, you learn about the motion, the composition from the spectral lines. You can learn about the temperature, and you can get a much better understanding of those and a much easier time to see some of the very faint objects that would require incredibly long exposures on a photographic plate or could not even be seen with the eye. And you can see them much better because of the higher sensitivity of the CCDs. So let's go ahead and finish up here with our summary. And what we've looked at is we looked at the various astronomical detectors that are used to record images, really making a permanent record of the objects that we have seen. Modern telescopes use a charge coupled device, a CCD, to digitally record these images and spectra, which can then be easily and quickly shared with astronomers in different locations. So that concludes this lecture on astronomical detectors. We'll be back again next time for another topic in astronomy. So until then, have a great day, everyone, and I will see you in class.